Hey everybody, and welcome back to the Human Resource Machine. I love that music. Alright, we've got Vowel Incinerator. That's... yeah. Hi. Okay, all the vowels are gone. What's the meaning of this? Ahem. Management is attempting to reduce bandwidth by removing all vowels from every word. Good luck. Alright, send everything from the inbox to the outbox except for vowels. Alright, cool. So... actually, this needs to be I, and this will be X. So we're going to inbox, we're going to copy it to X, then we're going to copy from 0 and copy to I, because we need to start at 0. So this is our initial conditions. We inbox first because that means that when we loop back, because we're going to be doing this, we're good, basically. So, we are then going to... actually, we're going to do something a little bit more like this, but we'll get there. Alright, so, we are going to immediately copy from X and subtract what is at I. If it's 0, done. Otherwise, we're going to bump I, and then we are going to do it again. If it gets through all of that, we outbox it. No, I'm doing this wrong, I keep forgetting. We don't need to copy from X. We copy from what's at I, and then we subtract it. We subtract X from it. Then if it's 0, we know it was equal, we do that. But we also have a jump if 0 at the copy from I, which jumps to here. Because that means that we've hit the 0 at the end here. Alright, let's step through this and see if we've got the right logic going. Alright, so we inbox. Cool. We copy it to X. Yeah, I should just name that. Alright. We copy from I. Sorry, from what's at I. It's not 0, so we subtract X. It is not 0, so we bump I. And we start over. We copy from I, we subtract. Okay, so our first check here is that, oh look, it's 0. So we jump if 0, and we just inbox again, copy it there, we do that. I think this all works, but let's run through a non-vowel, watch it go. Then we've basically seen most of the paths. It's 0, so we outbox it. Whoopsie. We copy from X, and also this is 0. I think this works. It's gonna take it a little bit to run, but you can see why this works, hopefully. It's that fun little subtracting letters trick again. Now let's see how we did on optimization. We might be able to do one better. Nope. We got our size challenge and our speed challenge. Got it done too faster, because too faster. I'm going to save these hard ones for last. Just because I think it'll be. You're fired! Haha, just kidding. But I do have a note here from your other supervisor. She's out sick today. But she says it's time to eliminate inefficiencies, and that's it. So, notice how I just noticed that the building is falling apart. Send everything from the inbox to the outbox unless you've seen the same value before. Discard any duplicates. Okay, so this is going to be a little bit interesting. I like this. So we need to store everything that we've seen and compare everything that we've seen. So we need, so this is 0. This is I. Oh, we can't do that. Interesting. Okay. So the thing is, we don't have a null terminated string here. We don't have a 0. Alright. We can make this work. We can make this work. I think. Alright, so we need some initial conditions here. First off, our first one's going to the outbox, guaranteed. But we first are going to copy it to what's at 0. We kind of need to set up our initial conditions. If this keeps track of our current... This is where we have to do weird stuff, just for the loop management, basically. Because the easiest way, and the way that we've been doing it before now, has been 0 terminated strings. So I could copy from 0, copy to 1. Actually, we would do this. Copy from 0, copy to 1. We also need to copy it to I. Okay. So we have 0, 0, our first, and our 0 there. And then we need to bump that. So really that's not 0. We don't want that to be 0. Crap. We need to, the thing is we need to store a 0. We can't just put a 0 places, which is really annoying actually. Because in a real computer, technically these are all filled with zeros. And I say technically because that's not always necessarily true, but we could make it true very easily if we wanted to. Okay, we could go with negative. We could go with negative. If we call this the count, the count starts at 0. We inbox. We copy it. We know it's to 0. I'm specifically going to call this one out because we're doing that on purpose. We outbox it. We copy from count to I. And then we bump count. No, we bump count and then we copy to I. No, we don't. We don't bump count just yet. Shit. No, we bump count right away. It means we don't have to copy from count there. Let me copy this to 1. I need to be able to check if something's 0. So what this, let me show you what this does, so that it's clear. We unbox B. B is always going to be a thing, so we copy it. And we outbox it. So we bump count, and we copy it to I. Which is exactly what we want. We now have pointing and the number that we have, which is great. So that's our initial condition set up. So then we inbox again. And now we have to check and make sure that that is there. Great. We inbox, we copy it to X, because that's what we're going to be comparing it to. So then we copy from what's at I. Yes, we copy from what's at I. We then subtract it from X. If it's 0, we inbox. Right, if it's 0, they match. So we want to start over. There might be some other stuff that we need to do. Crap. Okay, well, we'll figure that out in a bit. It's not. This isn't gonna work. This isn't gonna work. Some stuff needs to change first. This is actually what needs to happen. It's annoying, but it'll make sense. We don't always want to bump it, is basically the answer. So I can't put this here. We need to copy from count and copy it to I. So if it's not 0, if they don't match, then we bump I. If it's 0, we're good. Then we copy from X. No, we then bump count. We copy from X. We copy to what is at count. And then we outbox it. And then we go back to here. If it's not 0, then we do it again. Okay, this got really convoluted really fast. So let's debug through it real fast. We inbox. We put A at 0 because we know that's always going to go out. We then bump count because we've got one thing. So we copy from count. It's a little redundant, but it's because we don't always need to bump that count. We copy it to I because we're doing an invert. We're counting down in our loop. So we inbox. We copy to X because that's what we're comparing to. So then we copy from I. We subtract X. It is not 0. We bump I down. Is I 0? Oh look, it is. So we bump count. We copy from X. We copy it to count. And we outbox. Okay, so that's our first case. Our first case is something new. So now we copy from count. We copy it to I, because that's our countdown. We then inbox and we copy it to X. Beautiful. So now we copy from I. We subtract X. It's not the same. So we bump down I. We jump if 0. It's not. So we go back. We copy from what's at I. We subtract X. It's not 0, so we bump I down again. Hey, is I 0? Yes, it is. We've compared with everything. So we bump count. We copy from X. We copy it to count. And then we outbox it. Okay, now here's our first duplicate case. D. We copy it to X. We copy from I. We subtract. Is it 0? Why, yes it is. So we reset our loop, and we do it again. Alright, so the interesting thing about this program, and I'm going to be curious to see in our optimizations because I'm about to hit this full speed, but I kind of want to give a prediction. There are two ways of doing this. One is the way that we're doing it now, obviously. We're starting at the end and counting backwards. The second way, which is the way that I was initially thinking about, was basically trying to keep a 0 here, so that when you loop through here. Now, we do get a little bit of weirdness because of this, but that's because we're trying to use 0. I could also technically use if negative, and maybe that's the way that I'm going to have to do it, but for efficiency's sake. But for right now, what's interesting is, depending on which way you loop, it's going to have a different behavior in terms of efficiency. This guards against a lot of things being used in a row better than anything else. Now, that's not 100% true. If we had a bunch of A's in a row, it would be really inefficient because it's last, but like the 3 D's in a row, it bumped them up real fast. It's basically it works a lot. It works best if you're using the same thing a lot in the same place. So we're using D's a lot in the same place, which means that it doesn't have to travel as far back down the row as it would otherwise. Now, the other way, where we start at the beginning, benefits you if what you use most commonly is used a lot. So if, like in the English language, the word the is used a crap ton. So if the first word in here would be the or something like that, then you'd hit it so often that it would be beneficial. Depending on what you're expecting as your input, you could technically tailor this loop to be more efficient for one of those cases. Or you could pick which one you wanted to do. But you'll notice that these just get destroyed, which is beautiful. And then this E should make it. I'm curious about our efficiency. We're not going to meet this, I don't think. Yeah. I hope we meet this. Nice. Okay, so. How do we remove 2 instructions? Well, I mean, I can kind of tell you. The answer is remove this. Instead of jump if 0, jump if negative. I think that actually fixes this entirely. We're gonna see though, it might not. So we copy from count. Copy it to I, we inbox X. Copy. Okay. Not quite. The problem is where the bumping occurs. Stop, 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 stop. I wasn't paying enough attention to realize what went wrong. I was the wrong value. we don't have to bump it. Because we're checking if negative. Alright, I think this works, but we're still one too long. Which is probably a jump, which means that I'm probably structuring this loop slightly wrong. Yep. Crap. If I could make this bump count. No, because it's the only place we bump count. So it doesn't matter where it is, because we don't bump it initially. So we have to copy. Once again, I can get this up top, but I'd have to do a downward bump somewhere to counter the fact that we'd be bumping an extra time. Shoot. God damn it. This sort of crap is really annoying to me. Like, that's literally the difference right there, is just that extra outbox. It just happens that we can make the code one line more efficient by utilizing an outbox. It makes sense, I get it, it's just annoying to me because the outbox is sacred to me a little bit. Alright, we nailed it. We've got time for another one. Cough, cough. Yes, it's getting a little drafty up here. Facilities management has been notified, but we still have work to do. Each pair on the floor contains data and the address of one of the other pairs. Oh, goody. I'll get there. A scrambled chain. Each thing in the inbox is an address of one of the pairs. Outbox the data for that pair, and also the data in all the following pairs in the chain. The chain ends when you reach a negative address. Repeat until the inbox is empty. Alright, so this is what we call a linked list. It's a data structure where basically you have a piece of data and it points to the next piece of data as well as having its own data. And that's exactly what this is. Like, E, this is the data, and then it points to the next bit of data, which is at 13, which technically is this entire thing. Technically it's pointing right here, but it's pointing to the start of it. It's just we know that the size of it is 2. So, yeah, it's a little weird, but that's how an inbox works. So, we need to inbox the data. Alright, so, inbox. We inbox 23. Cool. Well, let's call this the start. Because this is pointing to the address. So, we inbox. We copy to start. We copy from what is at start, and we outbox it. We bump start. We copy from what is at start, and we copy to start. If this is negative, no, not yet. Bump start, copy from what's at start. Okay, so we inbox, so we got 23 there. We copy to start, we copy from what's at 23, which is A. We outbox A. That's what we want to do. We then bump start, so then it's pointing at 24. We then copy from that, which is the address, and we copy it to start. So we want to jump if negative. Yep, this should do it. This should do it. Let's watch one. Let's watch it at least a little bit. Copy A, we outbox it. We bump start, because we know that the second piece of data is in the next memory address. It's not negative, so we're not done. So we copy it to start, and then we start over. I'm confident with this. It says escape. We are at one extra command, but we are right on time. So what is extra here? This is actually really freaking minimalistic. Oh. I hate this sometimes. So the D, like that, it's an interesting one. But we did it. Do I want to look at the next one? I want to look at the next one. Of course I want to look at the next one. Recoordinator. Oh, matrices! Oh, yes. Pawn to b6. And check, and mate. Yes, I win again. I find the game is most enjoyable when playing against the best player I know, myself. Each number in the inbox is an address of a tile on the floor. Send to the outbox the coordinates of that tile, column first, row second. For example, an address of 6 has coordinates 2, 1. You may ask your boss for more examples. Okay. So there's a couple different ways we can do this. Is there? So the answer is divisible by 4, and then remainder. So this will be an interesting problem. Do I want to start it now? It's a tempting question, actually. Note how they have a 4 there because that's so kind of them. Unfortunately, we're going to be... Oh, they just have this to show. Interesting. Okay. First, column first, row second. So remainder, then successful divide. Okay. We inbox I was hoping for matrixy math, so it's just whatever. So it's our numerator, and this is our denominator. So we copy to our numerator. Yes. We subtract the denominator. If it's negative, we're going to do something. Otherwise, we copy to numerator and we bump. I guess this is technically the answer. Well, no, that would be the row. Column, then row. So if it's negative, alright, so if we do that, then we have to copy from the numerator again. Do we? Yeah, because we're bumping the row. Alright, if it is negative, then we stop. We copy from... Wait, it is column first, so remainder first. So it is num. So we copy from num, outbox, copy from row, outbox, and then we do it again. We do have some initial conditions. That's going to be a 0 because we need to do that. We need to copy from 0. Actually, technically, we should put this down here. Copy from 0. Copy to row. Copy from that 0. Alright, let's check if this works. Alright, we need that. We need to be able to store that 0. We inbox. It's a 10. We copy to our numerator. We subtract from our denominator. Subtract our denominator. It's not negative, so we copy it to numerator. We bump row. We do it again. Still positive. Hey, look, it's negative. We copy from numerator. We outbox. We copy from row. And outbox. And then we put 0 back in the row, and our initial conditions are complete. And we're done. Actually, wait, I want to check the 0 condition. Actually, no, the 0 should be just fine. That was wholly unexciting. This is not going to be efficient, but... yeah. Too many commands, too long. But... it's really disappointing. I wanted something cool, and this is boring. Or, sorry, it's something we've done before. There might be a cool, like, a better way of doing it than this that's more efficient. But there's a way to do this that's more efficient than this. But it doesn't work? Shoot. So there's a way to do this that is silly and probably involves pointing things places. That's because there's not much I can take off in terms of doing this. There just isn't. No, I don't want to copy. I want to clear it. So division's not technically the way. So how do we do this? How do we get 10 to point to 2, 2 without explicitly dividing? I don't know. We could do something silly. Something silly. I don't think we can. There's something clever here, but I've talked about my opinions of clever code. Clever code is bad, and it should feel bad because division is pretty obvious. And I can't. Okay, so there's an interesting thing we could do here. Where we bump this, copy it to here, bump this, copy it to here, bump this. This isn't going to be efficient, but it would technically work. 1, 2, 3, 4. I guess 14's our limit. So if we inbox, copy it to here. We need to do row first? No, column first. We could layer this entire thing from 0 to 4 to, or from 0 to 3 to get the column. Like, we could do that. It's just that that's stupid. Like, it's not a good plan. We can't store multiple things in each column, so it really doesn't matter. We can't, or in each square, we can't store multiple things. Or you just store the coordinate and reference it with a copy from, or something like that. Like, that would be the easy way to do it. But you can't store all, like, you can't store 0, 1, 2, 3 here, you can't store 0, 1, 2, 3 here. So it's not particularly useful. Unless you recoat the entire thing in each direction, which is absolutely dumb, and you should not do that. So you have to find a way to get the column. You have to get the column, and then you have to get the row. Which is why you just divide. Any other solution except dividing to find the column and row is a clever solution that you do not want to use. But they're guaranteeing that we do it. Tell me more! 4 P's. Proper planning prevents problems. Okay, yeah, that's useless. I don't like what they're doing here. That's all I'll say. I don't like this puzzle. Because it's not about practicality. And I suppose that's part of the point of a puzzle. It's about being clever. But when you think practically, pragmatically, then a solution like this just seems like a bad idea. See, coding it is just a... It's just a bad idea. Although it would let the lookup be ridiculously fast. But what do we put in the squares? What do we put in the 10? Excuse me, I tried to turn away from the mic as fast as I could, but that was a randomly sudden sneeze. What do we put in the 10? Do we put a reference to 6? Because that seems like an even worse idea. Like, that seems like a really bad idea. At 6, we'd put a reference to 2. The problem is we have no way of labeling it properly. We have no way of telling it that it's at an end, right? We just don't have a way of doing that. So, if we coat this, the only thing we've got is 15 because we're using a 14. And we don't have any external memory addresses, which would be very helpful. We just don't have them. So, if we have 10 pointing to anything, it has to point to 2. That might work. No, it won't, because we have to manipulate the whole thing. We don't have enough memory addresses to manipulate the whole thing to make that a thing. Because the problem is, so what do we have 10 point to? Like, let's just think about it. How do we tell it to get our column? Well, our column is 2, so if we have 2's all down the line, that's great. But then what does that do for us, right? It doesn't really do anything for us. At all. Oh my god. Why? This is so bad. The subtraction, or the division was the right answer. Division is the right answer. Okay, I'm getting stuck on this. I'm getting stuck on this, and sitting here looking at it for a little bit longer isn't going to help. I probably need to just take a break and come back to it next week, when I've kind of forgotten about this whole debacle. Which means I'll try division again, knowing that it's the wrong answer, but I'll do it anyway, because maybe I can make it more efficient that time. It's just so stupid. Anyway, I'm gonna end up staring at this for an hour if I don't end the episode now. And I don't want just an hour of me sitting here going, this is silly, this is stupid, why am I doing this? So yeah, thank you guys for watching. I hope you enjoyed this episode. We're gonna figure this one out, and I'm gonna be really critical about why anyone would ever do this in this manner, and we'll deal with it from there. So yeah, thank you guys for watching. I will see you next time, but until then, keep your gears turning.